Every year, billions of people step onto an airplane globally. As these gigantic metal birds glide thousands of kilometers through the air, many of us wonder how they manage to fly so safely despite their massive weight and speed. Sometimes, that fleeting anxiety crosses our minds. What if something goes wrong? There is one comprehensive answer to this question, and it is the very name of our channel, Airworthiness. Welcome to Make It Airworthiness. On this channel, we will delve into everything from general aviation to the deepest secrets of technical aviation. In our first video, we will explore what airworthiness, the unsung hero of flight, truly means, and examine the incredible safety nets an aircraft must pass through before it touches down safely. If you're ready, buckle up. Let's get started. Part 1. What is airworthiness? Simply put, airworthiness is the official and technical status that certifies an aircraft is in a condition to operate safely for its intended purpose. This is not just about the plane looking good right before takeoff. Instead, this concept guarantees three fundamental things throughout the aircraft's entire lifespan. 1. Correct design. Was the aircraft designed according to international standards and regulations, ensuring safety even in the event of failure? 2. Correct manufacturing. No matter how perfect the design is on paper, was the aircraft built exactly according to that design and the highest quality standards? 3. Continuous maintenance. Has the aircraft been regularly inspected and perfectly maintained by authorized personnel throughout its operational life? Airworthiness is the entire equation that encompasses these massive requirements. No aircraft without this status can conduct commercial flight. Part 2. The shield of design and certification. An aircraft's journey to airworthiness begins while it's still on the drawing board. Engineers apply the most critical principle, accounting for every scenario in the sky: redundancy. What does redundancy mean? For any system on an aircraft, there is always one, and sometimes two or more, alternative systems available to mitigate the probability of failure. For instance, the flight control computers, the plane's brain, often have 3 or 5 layers of redundancy. If one fails, another takes over instantly. The hydraulic systems that move the flight control surfaces operate with separate lines and pumps. Even if one line completely fails, the others continue to control the aircraft. Once an aircraft is manufactured, it must obtain a type certificate, which guarantees all these systems are safe. The certifying authorities such as the FAA in the US and EASA in Europe confirm that the aircraft has passed the most rigorous tests, proving its reliability in every scenario, from icing conditions to the hardest landings. This certificate proves the design itself is airworthy. Part 3. The plane's health record. Maintenance and checks. No matter how robust the design, wear and tear over time are inevitable. That is why the biggest pillar of airworthiness is maintenance. Airlines keep a health record for every aircraft. This record contains meticulously executed inspection programs determined by the aircraft's age and flight hours. A check, performed approximately every 400 to 600 flight hours or 200 to 300 cycles takeoffs and landings. Usually completed overnight, C-check, more comprehensive. Performed every 18 to 24 months and requires a deeper inspection of the aircraft. The plane is taken out of service for several days. D-check, heavy maintenance, the most critical inspection in an aircraft's life. Typically performed every 6 to 10 years, the aircraft is almost completely disassembled and inspected down to its smallest component. This process can take months. During these inspections, special tests, such as non-destructive testing and DT methods, are used to detect metal fatigue, hairline cracks, or corrosion. Even the slightest crack found by a technician means the plane must be immediately grounded and repaired. Part 4. Failure management and the MEL list. But what happens if a failure actually occurs? People sometimes think that when one light illuminates on the aircraft, everything is over. However, the airworthiness culture assumes failures will happen and plans accordingly. This is where one of aviation's most important documents comes into play: the Minimum Equipment List MEL. The MEL determines which systems can be inoperable while the aircraft can still safely continue the flight. For instance, if one of the plane's 3 hydraulic systems is inoperative, the MEL rules might permit the flight but impose restrictions and require the malfunction to be rectified within a short time frame. If the failed part falls outside the limits permitted by the MEL, meaning it critically affects flight safety, the aircraft is strictly forbidden from leaving the ground. This list is essentially the practical reflection of the flawless redundancy designed into the aircraft. As you can see, a plane staying in the sky depends not only on the lift generated by the wings but also on a rigorous safety network created by hundreds of engineers, technicians, pilots, and regulatory bodies. Airworthiness is not a static state, it is a continuous commitment. So, next time you look out the window, remember that the plane is not just a machine, but an airworthy masterpiece, surrounded by thousands of checks, tests, and regulations. We've reached the end of the first video for our channel, Airworthiness. If this technical and exciting world of aviation interests you, please don't forget to like our video and subscribe so you don't miss our new technical content. In our next video, we could discuss the incredible engineering inside aircraft engines or how aviation accidents lead to new rules. Let us know your next topic suggestion in the comments. May your skies be clear. See you in the next video.